12.2 lesson is matrix multiplication. So we're going to take a look at a couple different types of multiplication. So the first type is scalar multiplication, where you multiply a matrix by a number. Okay, so for this first one, they want to take 2 times matrix A. So if we go ahead and write that, matrix A is 2, -7, -5, and 3. We want to go ahead and distribute that 2 to every number inside the matrix. So 2 times 2, we get 4, 2 times -5, -10, 2 times -7, -14, and 2 times 3 is 6. So that is going to be our answer. Now for this, we can use our calculator if we'd like to. So let's check our work that way. So we would go ahead and type in our matrix. So go to edit, and it's a 2 by 2. Go to graph clear, second matrix, just a second, type in the 2 first, then go to second matrix, go to matrix A is where we typed it in, click enter, and it's going to go ahead and multiply each of the numbers by 2 for us. Okay, now the next type of problem we're going to take a look at, we need to solve this matrix X. Okay, so it's just like 9.1, we want to solve for the equation. So to start off with, we are going to subtract this matrix over so we can get that 2x by itself. So then those will cancel out. So we have 2x equals, and then each of the corresponding elements we're going to subtract. So 10 minus 4 is 6. 1 minus -5, the two negatives cancel out, so we're positive, so 1 plus 5 is 6. -7 minus 1 is -8. -2 minus 12, the two negatives cancel out, so -2 plus 12 then is 10. And then from here, we still don't have that x by itself, so notice it's 2 times our x, so we need to then divide both sides by 2. And we're going to do that by dividing each number in this matrix by 2. So 6 divided by 2 is 3, 6 divided by 2 again is 3, -8 divided by 2 is -4, and 10 divided by 2 is 5. So then that should be our matrix. That if we wanted to check our work, we could just plug it back in here for our x. So 2 times our 3, if we're working with the upper left-hand corner, 2 times 3 is 6. 6 plus 4 is 10, and notice then it's equal to 10. And each of the corresponding elements should work out. So let's try another one of these. So for this one, we want to get the x by itself. So first, I would go ahead and distribute that 4 to each in this first matrix. So 4 times -2, -8. 4 times 3 is 12. 4 times 4 is 16. 4 times -4, -1 is -4. And then bring everything else down. And then from here, I'm going to subtract this matrix over. So then that cancels out. So I get -1/2 times x equals. And then we're going to subtract the corresponding elements. So 3 minus -8, two negatives cancel out, so 3 plus 8 is 11. 9 minus 16 is -7. -2 minus 12 is -14. And 6 minus -4, the two negatives cancel out to be positive, so 6 plus our 4 then is 10. And then from here, we want to go ahead and notice we want to get this x by itself. So we can divide everything by -1/2, or another way that might be easier for us is multiply both sides by the reciprocal. So if I multiply this side by -2, multiply this side by -2, these are going to cancel out, so I get that x by itself. So we're going to get x equals, and we're going to distribute that -2 to every number inside the element. So 11 times -2, -22. Negative 7 times negative 2 is positive 14. Negative 14 times negative 2 is positive 28. 10 times negative 2 is negative 20. And that would be our answer. And again, if we wanted to plug that back in and see if it ends up working, just check the corresponding elements. Now for multiplication, when we're multiplying two matrices together, it's a little bit different than how we added and subtracting. We're not just adding and subtracting the corresponding elements. So for multiplication, what I would first off recommend, the first matrix, putting it down here, the second matrix, putting it up here, and the order is important. So the first matrix is always going to come here, the second matrix is always going to go up there. And then from here, how it works, you're going to get this number, you're going to take this first row here and this first column here that line up. And you're going to start from the outside, work your way inside. So you're going to take 4 times 3 plus negative 2 times 1. And you're going to take the sum of that. Okay? So then to get to this spot, we're going to take still this first column, but then this second row. So you'll notice how we have it set up, it'll just line up with one another. So 3 times negative 3 plus then 1 times 7. Okay, and you just follow through. Then to get to this next spot, we take, now we're in the second column, so we take this second column and then this first row. So 4 times 6 and negative 2 times negative 5. And then 6 times negative 3 and negative 5 times 7. Okay, and then we're going to simplify each of those elements. So 4 times 3 is 12. 12 plus negative 2 is 10. 24 plus our 10 is 34. Negative 9 plus 7 is negative 2. And negative 18 plus 35 is negative 53. Okay, and then that would be our final answer. So again, multiplication is a little bit different. If you would check 4 times 3, the corresponding elements don't end up working if you try to do it that way. Now, another way that you can do this is using your calculator. So if you've been liking the graphing calculator for the matrices, you could go ahead and just type in the two matrices and go ahead and multiply them. So when we check our work for this one, go to second matrix, we have to then go to edit. We need to type in both of the matrices. After each number, make sure you click enter. And then we're going to type in the second matrix under B. And then we're going to type in matrix A times and then matrix B. And notice then we get 10, 34, negative 2, and negative 53. So for multiplication, you may choose to do it by hand or using the graphing calculator. Alrighty, for these on the bottom, it's checking to see, determine whether the product exists or not. So these are going to be yes or no answers. Now instead of either doing them by hand to figure out whether you can multiply them or not, or whether you taking the time to plug them into the graphing calculator, see whether they work or not, another way that you can do this is looking at the dimensions. So for example, notice matrix A is a 2 by 2. Matrix C is then a 2 by 2. If the inside numbers are the same, then yes, you can multiply them. If the inside numbers are not the same, then you would not be able to multiply them. The dimensions wouldn't line up with the rows and the columns. Okay, we take a look at B times A. Notice B is a 2 by 1. 2 rows, 1 column, and then A is a 2 by 2. So the insides are not the same. So if we try to go ahead and multiply them, they would not work. So those cannot multiply. Now if we go back to number 13, these ones we can multiply, and it's interesting, the outside numbers is what your answer is going to be, a 2 by 2 matrix. Okay, so those outside numbers are important, that we know, yes, it can multiply because the inside numbers are the same, and then the dimensions are what the outside numbers are. So the answer is going to be a 2 by 2. Alrighty, let's do one more of these multiplication ones. Let's take a look at number 11 when the dimensions are not the same. So if we do this first matrix down here, and the second matrix up here, okay, and then this first column and this row is going to line up here. So 2 times negative 1. Start from the outside, work your way inwards. Then plus 5 times the 4. And then to get this next spot, we're going to take this row and then this second column. So 2 times 3. And then 5 times 7. So this one, notice, is just going to be a 1 by 2 matrix for our answer. So 2 times negative 1 is negative 2 plus 20, so negative 2 plus 20 is 18. And then we get 6 plus 35. 6 plus 35 gives us 41. So that then would be our answer. Okay. And if we wanted to, before we took the time to multiply that, we could use what we learned down here to actually see if it would work out. So we could check our matrix and look at the dimensions. So to start off with, we know that this one is has 1 row, 2 columns, so 1 by 2. And this one is a 2 by 2. So notice the insides match up, so we would know, yes, it multiplies. And then the outside would be what the dimensions of our matrix is, so it's a 1 by 2, which our answer is a 1 by 2, so it works out.